Okay, for 2-7, here's the big change. Now, we're still doing rational, so we're still looking at fractions. We're also doing polynomial, which is back to x to the seconds and x to the thirds and x to the fourths and that kind of thing. But the big thing for this one is it's inequalities. Now, the graphs are a lot easier on this one because the graphs, we're not doing x and y axis. This one is strictly just an x-axis. It's a number line is what we're going to look at on this part. So this is just graphs on a number line when we start looking at the graphs. And these are going to be really, really, really straightforward, really simple graphs when it comes down to it. Now, because we're actually getting back to number lines, let me back up for just a minute, make sure we got it here. Just backing up to make sure everybody remembers, because this one you actually have to graph on the number line. They're probably going to make you, we'll go back and forth, because they may let you use the circles, but they may also make you use the parentheses and brackets, so we'll hit both of them here. If you have a problem like this is x greater than 2. Again, if it's greater than, you're going to use the open circle. If it's less than, you use an open circle. You know, and as long as you put the x first, this arrow of the direction, the greater than less than symbol, always matches this arrow. As long as you put x first, you're good to go. Now, if they ask you not to use, if they ask you to go back to the parentheses, this would also be on the number line. If they have you use the parentheses and the square brackets, this one would be a parentheses at 2, headed to infinity. So just remember, if you have an open circle, that's the same thing as parentheses. Parentheses on the homework? Okay. So if you're thinking back to graphing this one, you know, if you think about graphing with open circle, just remember you're going to use parentheses. If you had, you know, x less than or equal to 4, equal to is a solid. Oh, and if you think back to how the graphs used to have, that would be a solid circle at 4. And again, this arrow matches this arrow as long as x is first, so this would basically be going like this. But with the brackets and parentheses, at 4, you're going to have the square bracket point to the left. So it's either, so if you have a solid circle, or we were doing this before, this is where you're going to use a square bracket. Where if you had the open circle before, now you're going to use parentheses. So just making those two little changes when we're going through the graphs. Okay. And again, as long as you put, and that's the one thing I always try to tell people, you know, keep the simple things simple. Put x first. This arrow always matches this arrow. They always have to be the same. Okay, so here's what they're going to do. They're going to give you, we'll do the polynomial part of it first. They're going to ask you to graph something. And again, they shouldn't be too awfully complicated. We're going to do x squared minus 5x plus 4. And instead of it just being equal to 0, now they're going to have it so it's greater than or less than or equal to or greater than. They're going to give you one of the inequality symbols here to go with it. All right, now here's when you're going through and graphing this. A couple things you have to do. Basically, pretend this is not an inequality. Pretend it's an equation. So we're going to solve the equation to find the, and everybody calls it something different. It's either inflection points. Some people call it, what's the numbers I'm looking for here? Inflection points. Some people call it break points. Some people call it, they've got all kinds of different names. But basically, these are your solutions that you would have. And then these are going to be points that's going to break the graph up into sections. And those boundary points basically separate answers from positive to negative, and that's going to be basically the numbers that you're looking for. And then the one thing that's similar but still going to be easier than we did before is you're going to plug a value, because basically once you get the boundary points, you break this number line up into regions. And you just have to plug in a value in each region. Not values, how about just a value? So plug in a value in each region to see if that region is true or false. And if it's a true value, you shade that region. If it gives you a false value, you don't shade it. Now, this will be easier than what we were doing back in 2.6, because in the last section you had to plug in values on each side, both sides of the aspect. This time, no, it's just you've got a region, you're plugging numbers in, and then you see if it makes it true or false in the inequality. So, see if it's true or false, we'll say in the original, because you have to go back to the less than, greater than part. So, part 1, you're going to treat it like an equation. Part 2, when you plug the values in, you actually go back to the original and see what's happening there. Okay, so we're going to take x squared minus 5x plus 4, and then again for step 1, we're going to let that equal 0. Which means basically you're going to factor. Should not have to do quadratic formula. This should all be factoring, so there should be just easy whole numbers to find. The factors of 4 to get you 5. It's got to be 1 and 4. How about 1 and 4? Let's put a 1. There we go. Okay. Signs negative. Bigger numbers got to be negative. And if you divide a negative and a negative, sorry, if you divide a positive and a negative, that'll make that a negative. So in that case, they're both negative. So one boundary point is at x equals 4. Other boundary point is at x equals 1. Okay, and that's the only two numbers that we need on our number line. One and 4. That's it. So everything we're going to do from here, we're going to be drawing either an open, well, not open circle, closer. In this case, we're going to be drawing a parentheses and a bracket at those values, and then you're going to figure out what parts you're going to shade in. Okay, so you've got to pick, basically you've got from negative infinity up to 1, so you can pick any number you want from negative infinity to 1, plug it back in and see what happens. Because 0 is in here, let's plug in x equals 0, because that'll make this thing a lot easier. Because 0 knocks out the first part, knocks out the second part, it leaves it so it's 4 greater than 0. And then all we're doing is we're plugging in x equals 0 to see does it make it true or false. Well, that's 0. It's also 0. That's 4. Zeros don't matter, so is 4 greater than 0? It is, isn't it? That's true. So we're going to shade in everything back here on this side, going this way. Now, how you know if it's open circle, or in this case, parentheses or bracket, go back to the original problem. It was just greater or less than. So where that would be an open circle, now it's parentheses. So now, and as long as the problems aren't too complex, if they're pretty straightforward, they should alternate, but you still have to plug numbers in just to be on the safe side, because sometimes problems that look really plain and simple, you check them and they're not as plain and simple as they think. There's always some possibility of something being weird in there. So even though it should most of the time kind of alternate, if the problems get, the more complex they get, the less they follow certain rules. So for here, we're going to plug in x equals 2 or 3, doesn't matter, and just see what happens here for that part. So it's 2 squared minus 5 times 2 plus 4 greater than 0, and that's our question mark. Is that true or false? So that's 4 minus 10 plus 4. Negative 6 plus 4 is negative 2 greater than 0. That's no. So that's a false. So we're not going to graph anything in here. And again, as long as it's not too complex, if this is true, false, it should follow that this one's true, but just plug it back in just to make sure. So over here we're going to plug in x equals 5. Again, you can pick 6, 7, 8, 9, 10. Any number to the right of 4, we're good. That's 25 minus 25 plus 4. That's 0. Back to 4 greater than 0, and that is true. Well, let's check it and see. If we check 1, now 1 is on, it's on that boundary point, so we don't check it because we already got the 1 back here from this part. So that's our cutoff line. That's our state line, if you want to think about it that way. Yeah, if we go back to like the vertical asymptotes and the horizontal asymptotes in the last section, that's basically you would have a vertical asymptote right here. So that's your cutoff line. What's going to happen? It's either this side or that side.
That's why one back.
For that one, yeah, if you put 1 back in there, yeah, you would get, and then back in the original, you would have 0 greater than 0. Well, is that true or false? 0 is not greater, it's equal, right? So if it's equal, that still makes it false. That's why you can get really close to 1, but you can't touch it. So it's that boundary line of, all right, this is as far as you can go, can't get there. Yeah. Now that's what you're thinking, is that if, and that's the only difference of these two problems, is that if we had this bar underneath it, where it's greater than or equal, then the only thing you would do different is down here for these problems, instead of using the parentheses, yeah, you put the bracket, which would include that number because 0 would equal 0. Yeah. Then you have to use the parentheses. So it's not included in that point. Yeah. Okay. All right, let's get one more of those. So let's go 2x squared plus x. Let's go less than 15. All right, very first thing with this one is it's not equal to 0. So the very first thing you want to do is move that 15 over here so that this is equal to 0. I'm right against the bottom of the page, so let me rewrite that over here. Okay, so from there, again, you're back to factoring on this one. Now, this one has, because the first number is 2, again, to get the boundary points, we're going to ignore the less than for a minute and just do it as an equation. If we'll put a 1 in front there, we'll do that just for a minute. Because the first number is something other than 1, that means we're going to have to do the AC method. So we're going to start by doing 2 times 15, negative 15. So that's negative 30. So we're going to do the factors of negative 30, where the sum would equal positive 1. So not going to be 1 and 30. Not going to be 2 and 15. Not going to be 3 and 10. But it would be 5 and 6. And with the sum being plus 1, that plus always goes with the bigger number. And if you do a negative divided by positive, that means the other number is going to have to be a negative. Okay, I'm at the bottom of the page. Let me jump to the next page here. So we've got negative 5 and a positive 6. Okay, now again, here's where everybody does something a little bit different, but everybody kind of agrees on that point. For me, the way I teach this, we're going to have x minus 5 and x plus 6. But in the beginning, we multiplied by 2, which made the number everything twice as big. So now, to even it back out, we're going to go back and divide everything by 2. Now, this one doesn't simplify, so just leave it 5 over 2. This one does simplify to get x plus 3. And since we're looking to solve and not factor, instead of doing the bottoms up where you would take the 2 and pull it back up in front, actually go ahead and solve both of these numbers. This one just setting that equal to 0. Now if you want to change that back to decimal, we can. X would equal 5 over 2, or 2.5. And for this one, we would just subtract 3, so x would equal negative 3. And those are the two boundary points. Now, that one's a negative, or, sorry, that one's a decimal. When you get to the 2.5, that's a decimal. It's not that big a deal because, again, you're just going to pick whole numbers. You're going to pick any number in between these three regions that you have and just see what happens. So if that's a decimal number, that's fine. It's not a big deal. The only thing is that's just the boundary point. And because this problem, let me flash back real quick, was less than, actually let's go back and make this one less than equal to. And if you want to, on these, you can go back to the original here, since all we did was just subtracted this 15 over to make it here. If you want to go back and plug it back in here to compare it to 0, that's fine. So for this one, we're going to go back and compare everything to 2x squared plus x minus 15. Let's go less than equal to 0. And because it's less than equal to 0, when we do these numbers, it should be square brackets, whether it's this way or this way. Same thing here, this one should be a square bracket depending on which way we go there. So less than, equal to, greater than, equal to, always square brackets. If it's just less than or just greater than, then you're going to be using parentheses. Okay, so any number to the left of negative 3. Alright, we'll go crazy and go negative 4. Again, if you want to go negative 10, negative 100, you can do that. Plugging that back in here, we get 2 times negative 4 squared plus negative 4 minus 15, and then the question mark is that less than or equal to 0? So that makes it 2 times negative 4 squared is 16, plus negative 4 is just a minus 4 minus 15. That's 32 minus 4, which is 28 minus 15 is 13. Is 13 less than or equal to 0? No, it's greater. So we're not going to shade in that region. And again, as long as it's not a too complicated polynomial that we're looking at, it should alternate. So it should be that the next region probably is true. And again, I picked 0 because 0 makes this one really nice and easy here. Because if you plug in x equals 0, everything here is gone. So you get 0 plus 0 minus 15. So is negative 15 less than or equal to 0? Again, really you don't have to worry about, is negative 15 less than 0? Yes, it is. So that part's true. And again, the only thing that the bar underneath it does is it tells you when you graph that part, you have to use square brackets. That's all that's there, is that's saying, all right, negative 3 works, and 2.5 also works. And every point in between, that's also going to work. If you take that bar away, the only thing we do different is we do parentheses instead of square brackets, meaning negative 3 would make it still not true. It gets close, but it's not quite. Right, and if you check one more number, and again, if you want to pick 2.6, go for it. But I'm going to go a whole number. Let's pick x equals 3 and see what happens. As long as this is not too complicated of a problem, x equals 3 is probably not going to be true. Because we've got 2 times 3 squared plus 3 minus 15, so that's equal to 0. 3 squared is 9. 2 times 9 is 18. Plus 3 is 21. 21 minus 15 is 6. Is 6 less than 0? That's enough. So that part's false. So for that problem, that is your answer right there. All right, now let me show you, and this one we may not even graph it. Let me just show you one more thing, one more graphing one that sometimes it's good just to see some graphs that pop up, because sometimes people get a little bit confused on these problems because it's not necessarily the graphing, it's just the factoring part of it. So for this one, let's do x to the third greater than or equal to 9x squared. Okay, it's not equal to 0. So very first thing is, let's move this back over to the left side so it's compared to 0. So we have x to the third minus 9x squared greater than or equal to 0. So to get the boundary points, we're going to solve this equation equal to 0. Okay, so and again, here's the big thing, is x to the third, so we're looking for 3 answers. But it's only 2 terms, so you've got x to the third and 9x squared. The only thing you can do in the beginning, because of how this one's set up, is that because you've got x to the third and x to the second, they both have x's in them, so let's take that factor, that greatest common factor, out. You can take out an x squared from this one, that'll leave you with an x here. Take these 2 out, leaves you with a 9. So it's x squared times x minus 9. So you just take x squared equal to 0, and then x minus 9 equal to 0. So for this one, we've only got 2 boundary points. Zero and 9. Okay, so everything to the left of 0. So pick any negative number we want here and plug it in. Negative 1. All right. And again, I'm going to go back to this inequality where it's greater than or equal to 0. That way we're compared to 0, so it's a little easier to plug in there. So we've got x to the third, which is negative 1 to the third, minus 9 times negative 1 squared. Is that greater than or equal to 0? So that's negative 1 cubed, that's negative 1. Negative 9 times 1. So that's negative 1 minus 10 greater than or equal to 0. That's negative 11 greater than 0. That is definitely not true, so that's false. Oh, sorry. Not 10, not 9. That's negative 10. There we go. Still false. Okay, got lucky. Made a mistake, but didn't hurt me there. Okay, so that part didn't work. Going from 0 to 9, let's check on that one. X equals something in the middle, 3 or 4, maybe. So that's 4 cubed minus 9 times 4 greater than or equal to 0. 4 cubed is 16 times 4, 64. Minus 36. That's 28. Definitely greater than 0, so that part is true. That one we had the square bracket, so that would go there. Okay, and then pick some number out here, x equals 10. Okay, so that's 10 to the third minus 9 times 10. That's 1,000. Minus 90, so that's 990. Wait, that's squared. Whoops, my bad. Oh, that's squared. Hold on. Forgot my squared. Wait, did I get it back here? I forgot to square that one, didn't I? Let's make all kind of mistakes here at the end. 4 squared is 16. 16 times 9 would have been 114. Oh, sorry. My bad. Let me back up here for a minute. Yeah, because that should have been 4 squared. That's 9 times 36. 36, 9, 20. That's 314. It's like negative 250. So that was not true. Huh? Making all kinds of mistakes here at the end. Alright, so that one's false. So let's take this back out. Okay, 10 squared is 100. 9 times that is 900. Okay, so that one is 100 minus 900. It's not 990. That's 100. I started looking at something. I was like, wait a minute, we forgot back here. Squeezing in the top spaces and it threw me off here. 100 is definitely greater than 0, so that part would be true. So square bracket here. And it heads off this way. Got to throw some shade on. There you go.